Welcome everyone. Here is another question from GATE PYQ series. The question is, a 100 ml solution of pH 10 was well mixed with a 100 ml solution of pH 4. The pH of the resultant 200 ml solution is, and we need to report our answer up to 2 decimal places. So as we all know, pH we can calculate via using this formula, pH equal to negative log of hydrogen ion concentration. So first we need to calculate the final concentration of hydrogen ion in the 200 ml solution. And to calculate the concentration of the hydrogen ion, we need to first calculate the number of moles of hydrogen ion in the individual solution, because remember, we cannot add up the concentration together. So first we need to calculate the moles of the hydrogen ion present in the 100 ml solution of pH 10 as well as in the 100 ml solution of pH 4. So we all know how can we calculate the moles. Molarity equal to moles of solute divided by volume of solution in liter. And for the first case, first we need to calculate if I have to calculate the moles, I first need to calculate the concentration. And as given, it's given 100 ml solution. So this is going to be the volume given here is 100 divided by 1000, which is 0.1 liter. And the pH is given equal to 10. So we all know pH is negative log of hydrogen ion concentration. And for the first solution, it's given pH 10. So if I have to calculate the concentration of the hydrogen ion, it's going to be anti-log minus 10. And if we'll calculate this value, this is going to be 10 raised to power minus 10. You can make use of a virtual calculator available on the screen during the exam time. Now, we have calculated the concentration, which is 10 raised to power minus 10. So the moles is going to be for the first one is going to be 10 raised to power minus 10 into 0.1 liter, because remember, moles we can calculate by multiplying the molarity with the volume of solution in liter, and this is going to be 10 raised to power minus 11 mole. So this is for the solution 1. Similarly, we need to calculate it for the other solution, the moles. So pH equal to negative log of hydrogen ion concentration. And if I have to calculate the hydrogen ion concentration, that is going to be anti-log of minus 4. And this is going to be 10 raised to power minus 4. I mean, it's a simple thing. If it's pH 4, the concentration is going to be 10 raised to power minus 4. As we have seen, even for the previous solution, the pH given was 10 and the concentration came out to be 10 raised to power minus 10 because of this particular formula. So the concentration is given, the volume is given. So the moles is going to be 10 raised to power minus 4 and the volume of the solution is 0.1 liter, and this is going to be 10 raised to power minus 5 moles. So what we need to understand that this particular solution, which was carrying 10 raised to power minus 11 mole, was added to this solution, which was initially carrying 10 raised to power minus 5 moles of hydrogen ion. And what we need to calculate is the pH of the resultant 200 ml solution. Now, what we can do, we can calculate the pH. So let me redraw this diagram. So initially for the first solution, it was, so the volume given was 100 ml, pH given was 10. Concentration of hydrogen ion we calculated was 10 raised to power minus 10, and the moles was 10 raised to power minus 11. Similarly, for the other solution, the volume was 100 ml, pH given was 4, and we calculated the hydrogen ion concentration to be 10 raised to power minus 4. by making use of the formula pH equal to negative log of hydrogen ion concentration and the mole equal to 10 raised power minus 5. Correct? Now, what is asked is the pH of the resultant 200 ml solution after adding this volume into this beaker. So what we can do is now we can add the moles of the hydrogen ion. You cannot add the concentration, but I can add the moles of the hydrogen ion in this particular beaker. So this is going to be 10 raised to minus 11 plus 10 raised to minus 5. And what is the volume? Now the volume has become 200 ml. So 200 divided by 1000. If you all can recall, I described this formula molarity equal to moles by volume of solution in liter, and that's all I'm doing. I'm adding up the moles and then I'm dividing it with total volume in liter. And if we'll calculate this, this is going to be 5 into 10 raised to minus 5 molar. And that's what we want, because in the next step, I need to calculate the pH, which is nothing but a negative log of hydrogen ion concentration. And we have already calculated the concentration of the hydrogen ion. So putting these values, we can calculate the pH. And if we'll solve it, we'll get the value of 4.30. So the final answer is 4.30. And what you need to understand, this solution was initially basic and this solution was acidic because less than 7, this is more than 7. And after adding this solution into this solution, the overall pH has become 4.3. It's an important concept-based question. I hope this answer is clear to each and every one of you. If not, feel free to comment in the comment section. Thanks for watching the video.